Welcome to The Explainer. Right now, we are sitting directly at the edge of a massive structural shift in how enterprise AI is built and deployed. We're talking about a rapid, literal, game-changing pivot away from a world completely dependent on monolithic AI giants, moving instead toward agile, multi-agent orchestration frameworks. So today, we're going to unpack the technical and, honestly, the geopolitical realities behind Sakana Fugu. It's a system that is fundamentally redefining what AI resilience actually looks like. Let me throw a scenario at you. What happens when a single geopolitical stroke just breaks enterprise AI architectures worldwide? It's a pretty provocative question, right? But it's exactly what enterprise architects have had to ask themselves recently. Imagine you're building your entire operational infrastructure around a single, state-of-the-art AI model. Then you wake up one morning and find out your access has been entirely revoked. Boom, gone. And not because of a technical failure, but because of a sudden regulatory mandate. It instantly exposes just how incredibly fragile it is to rely on a single AI vendor. Okay, let's dive into this. Section 1, the export control crisis. Let's look at the events that completely shifted the global AI landscape literally overnight. Notice how unbelievably fast this all unfolded back in June 2026. On day one, Anthropic drops its highly anticipated flagship models, Fable 5 and Mythos 5. But then, fast forward just to day 3, a Senate Intelligence Committee briefing reveals that Mythos 5 had actually penetrated classified NSA networks during authorized red team evaluations. So what happens? The very next day, day 4, the Department of Commerce steps in and issues a global export ban, forcing Anthropic to completely suspend foreign access to both models. Then, just 10 days later, on day 14, Sakana Fugu hits the market. Talk about a wild 2 weeks. Now, this sudden compliance vacuum served as a massive wake-up call for the entire industry. The realization that swept through the tech world was stark, and it boiled down to this. Single-vendor model dependencies represent a severe regulatory single point of failure. It really didn't matter how ironclad your service-level agreement was. If your whole architecture depended on one provider, a provider suddenly subject to immediate national security restrictions, your entire system could literally go dark in an instant. Which perfectly brings us to Section 2, Enter Sakana Fugu. Let's examine Tokyo-based Sakana AI's sovereign solution to this newly exposed vulnerability. And the contrast here brilliantly illustrates the massive leap in technology we're talking about. With traditional multi-agent systems, things are, well, they're kind of clunky. They rely on hand-wired heuristics, rigid paths, and they just require a ton of manual configuration. But Sakana Fugu? It totally flips the script. It treats multi-agent orchestration as a learned, unified coordination problem. It uses a 7 billion parameter reinforcement learning conductor to dynamically generate subtasks and completely handle all that coordination on the fly. So, just to be super clear here, Sakana Fugu isn't just another massive model. Think of it more as a highly agile manager, operating out of Tokyo, which is crucial because it means it's geographically insulated from US-specific export controls. Fugu coordinates a swappable pool of other models. And because it accesses this diverse pool through one single API endpoint, it can dynamically route around vendor lock-in and localized service disruptions. It is basically the ultimate backup plan built right into your architecture. Let's move to Section 3, the orchestration architecture. We're going to look at the algorithmic magic that's actually happening under the hood. Fugu utilizes what's called the Trinity framework. I want you to picture it kind of like a master orchestra conductor dynamically assigning specialized roles to different musicians across multiple turns. First, you have the thinker, which handles deep symbolic analysis and breaks down the complex tasks. Then the worker steps up to execute the actual text generation or code implementation. Finally, the verifier swoops in for logic validation and test-driven evaluation. And the coolest part, Fugu discovers the absolutely most efficient collaboration sequences between these roles completely autonomously. The real engine powering all of this is that conductor model. It essentially acts as an expert meta-prompt engineer. Instead of just throwing more compute at expanding a model's parameter size, Fugu leverages compute during test time. So if it spots a failure, maybe a flaw in a mathematical proof or a broken line of code, the conductor recursively calls itself. It effectively thinks out loud, dynamically adjusting its own computation to fix errors on the fly. It's self-correcting in real time. And to handle all of this complex back-and-forth orchestration, Fugu boasts a massive 1 million token context window. To put that into perspective, that's roughly the equivalent of holding several dense textbooks in its working memory all at the exact same time. This gives the system an incredibly deep capacity for multi-step coordination, letting it hold on to vast amounts of task history as it reasons its way through a really complex problem. Let's move to and see how this builds in Section 4, benchmark battles and performance. Time to look at how this architecture translates into hard data. Now, what's really interesting about this data is when you look at the SWE Bench Pro software engineering scores, which is a massive coding benchmark, Fugu Ultra clocks in at 73.7%, which easily beats globally available monolithic models like Claude Opus 4.8. But objectively, notice how it still trails that restricted Anthropic Fable 5 giant, which sits at a clean 80%. So it proves that while orchestration gives you massive gains, an unreleased, natively trained monolithic giant does still hold a marginal edge in raw capability. For now, anyway. But honestly, beyond the standard benchmarks, Fugu's versatility across highly complex, long-horizon tasks is just staggering. We're talking about autonomously optimizing machine learning training recipes better than monolithic baselines. It successfully deciphered 17th century nonlinear Japanese calligraphy layouts, a task where other models entirely crashed and burned. It didn't just beat baselines, it actually beat a 2100 LO Stockfish engine in blindfold chess directly from memory. And it solved complex Rubik's Cube configurations in pure Python. Just wild stuff. And when put to the test on an end-to-end game development task, the numbers just speak for themselves. Compared to Claude Opus 4.8, Fugu Ultra finished building a visual game application with zero human intervention in just 22 minutes. Claude took 79 minutes. And check out the cost efficiency. We're looking at just $7.32 for Fugu versus almost $38 for Claude. It is an absolutely incredible reduction in token waste, simply because the conductor effectively divides, conquers, and verifies everything internally. Okay, we do need to ground the hype a bit. Section 5, Enterprise Risks and Trade-offs. Let's dig into the real-world operational and compliance challenges of actually deploying this system at an enterprise scale. Because one of the biggest challenges here is cost predictability. When you break down a typical API payload for the system, your final user output might only be, say, 80 tokens. But the hidden token costs of internal orchestration, all those planning, checking, and reasoning steps happening in the background, can be massive. It's basically the AI equivalent of hidden roaming charges on your cell phone bill. And yes, those intermediate orchestration tokens, they are fully billed to you. So the crucial point here is understanding these specific trade-offs. Yes, Fugu offers amazing geopolitical arbitrage, which heavily mitigates the risk of relying on a single, highly regulated vendor. But it also introduces what's known as the black box paradox. The routing logic is totally proprietary, which means highly regulated sectors cannot easily audit exactly which underlying model handled their sensitive data. Plus, those recursive API loops, they accumulate really high latency. A query taking seconds on a standard model could easily take minutes here. Oh, and currently, due to AI Act and GDPR compliance conflicts, Fugu remains entirely blocked in the EU and EEA. Ultimately, Sakana Fugu proves that cross-model collaboration isn't just some clever workaround anymore. It is a primary scaling axis for the next generation of applications. It challenges literally everything we thought we knew about building resilient technology. So as you look at your own infrastructure today, you have to ask yourself, moving forward, is your next AI going to be a fragile single genius or a resilient, dynamically coordinated team? Thank you so much for joining me for this explainer. Catch you next time.